name is Anoush. I am based here in the Boston area. And one of the reasons we're doing this is, yes, to come together and hear from you about your work. And also so we want to hear about your work. We want more people to hear about your work and learn about the awesome things you're doing and how they can collaborate with you. And maybe share something about how such sessions can be pulled together. We have certainly, at NeurIPS, we have benefited from the shoulders of giants we have stood on here, where women, Black in AI, queer in AI, Latinx in AI existed when this small effort started. So we could tap into those intersectional communities, disability in AI. In fact, the co-founder of Disability in AI was one of the first speakers at the inaugural Women in AI Ignite. Okay, Maria is somewhere in this picture. So these are the reasons to do it: to learn from you, provide a platform for your work, and maybe inspire us to do something at other conferences that could stand to have more women and other marginalized folks amplified, share something with these conferences about what they can do. So as part of our path to get here, we certainly have tried to do that and have done some activism like this at other conferences, like the Open Data Science Conference and some of the other sort of research conferences like ICML. Anyway, so that's the why. And then I wonder if Ting, you want to add something and say something about yourself, what you work on, and then let's jump in.
Sure. My name is Ting Su. Both Anoush and I work at MathWorks. So currently I lead the engineering team at MathWorks, and my team focuses on ensuring MATLAB deep learning or machine learning products work with other open source deep learning frameworks like PyTorch or TensorFlow or whatever. So I'm here to meet the amazing women machine learning researchers or practitioners in the AI community. I want to hear amazing stories from you. All right, next.
Okay, wonderful. So Ting, thank you for that introduction and for being brave with all of us on this journey. So today, we have a powerful lineup of you who will speak, and we will go in this order that we have on hand, but we will hear from Baessas first, and there are ground rules, okay? And these ground rules, like other ground rules in life, are sort of help us stay on task and make sure the right things are happening. And also they kind of, like a frame provides a beautiful way to see a picture. They provide a way to frame our work in fair and powerful session like Women in AI Ignite. So Baessas, take it away. I'm gonna stop sharing so you can share, because I think that's what needs to happen here.
Nope, I'm muted. Okay, can you guys hear me now?
Yes,
great.
It's awesome.
All right, so let's get started. I'm excited to kick off the first talk at Women in AI Ignite here at NeurIPS, or everywhere at NeurIPS 2021. So I'm going to talk today about something I think about a lot, and that's divergence between deployed machine learning systems and research. And I'm going to give two examples from dataset logging. So I really want to talk about this just kind of topic about how production machine learning practices differ from research and training. So for example, you can go do tutorials or in the classroom. And I want to give two examples here. So one is dynamic and streaming data sets. not just static ones. So when we learn about machine learning, we often, and even for research, we often use static data sets. You have a data set, it's ImageNet, it's something else, and it doesn't change over time. But when you're in industry or in any production model, your data set does change. It's dynamic. It may even be streaming. So very quickly at individual points instead of batches. The other one is profiling large data sets and not sampling. So when I encountered kind of machine learning at the scale that I see it now, until then, I didn't understand the idea of having to throw away some proportion of your data every day. But now that I'm working at scale, that absolutely has to happen. And so it's important to think about practices and learn about practices in industry so that we can just help kind of practitioners and help researchers to better deal with scale and all of the issues that that seem to be diverging between the two communities. Okay, so now back to the intro. Why do I think about this stuff? Well, I have two legs many of us have two legs, most of us. One leg of mine is in industry. I am a data scientist at Y Labs. Y Labs is a Series A startup in the AI observability and monitoring space. And we've created and maintained an open source logging library that uses some really cool statistical profiling and data sketch techniques to be able to really scale very large and work in real time. My other life, the other leg, is in at the University of Washington in the eScience Institute. And that's a data science institute on campus where we work very broadly, but my work is related to evaluation metrics, generalization and interpretability for machine learning. I also teach a software for data science class and am one of many working on our data science for social good program. Prior to that, I worked as a software engineer at Amazon. And prior to that, I'm a researcher doing statistical research at Morgan Stanley. So you might see that I bounced in before that undergrad. So before that, I bounced a lot between industry and academia, and I left them both. But I really like to think about this divergence and how we can bring more people together to think about these ideas and just spread that knowledge to those who are interested and could use these practices. So another reason I'm really interested in industry and kind of the relationship between research and industry is there are a number of deployed machine learning systems that have huge impact on the world, some very negative, some positive, but the impact is enormous and something that I think all of us have probably thought some about in the last couple of years. All right, so with that, I want to talk back to our first example. So dynamic and streaming data sets, not just static ones. Okay, so as I said, many of our data science resources have static data sets. Maybe it's MNIST, maybe it's some other set of images, maybe it's brain scans, so on. But realistic data sets, this is just a data set that I pulled online from a bike sharing company. This has timestamps. This data set has been growing over time. And so you really need to consider kind of how do you operate with data sets and metrics that change over time and are dynamic. So you can see here kind of a distribution that is changing over time. And this is really important. Sometimes I go back and forth on whether or not this is a very siloed, industry-specific, problem-specific set of skills you need to have, or whether or not we should all be thinking about this at least a little. And I went to Kaggle and just did a analysis of the top 40 data sets at the time, and 14 of those 40 had some time or date index column, which for those cases likely meant that when those data sets were being created, they were coming in, dynamically at different times. And so we can look at this another way. We can think about our data set. We have a static training data set on the left, and we might split that into train, validation, and test. And you'll have experiments and training and evaluation. And eventually, you will need to retrain because your model will get out of date. Your data will get out of date relative to the world. And so you, in the static realm, kind of think of this as just creating a new data set and starting this flow over again. But we could think about data like this. So we start with a static data set still, but we're constantly adding to our data set, just small bits of data. And this flow happens a little bit more naturally. So what does that mean if you're a data scientist or machine learning researcher who wants to start dealing with real-time data? Well, you have to think about a number of things. I only highlighted one here, and that is, how do we do evaluation? On maybe the more extreme example is the online machine learning model case. But in lots of other examples, just this timing and the realities of data arrival really do affect things all the way through. And even stronger, so on the production ML systems I've worked on, the data is streaming. There's no chance that we're going to keep batches of this. There's so much data. There's terabytes of data coming at any time. So how do I deal with this at the kind of extreme of dynamic? All right, and then so quickly, let's get into sampling and profiling data sets. So if you have a lot of data, and you're in this case with a lot of data, and you need to retain some of that data, what you may do is sample. As a practitioner, I do this. I've done this often, but this lacks accuracy at the tail. So if you think about the most extreme cases, which are probably important to you to understand where your model is going wrong, you likely are going to miss examples from the tail, and it's going to be underrepresented. So one option for that is profiling. So profiling involves kind of taking a look at each individual data point and then collecting some important statistics on that. So you may collect the max and min, partially a CDF or any other things. And what you can find is that you can get much, much better estimates of a number of metrics using profiling versus sampling. So in these two charts, this is error. So the lower, the better. And so this is why we've worked on this kind of open source data logging library called YLogs to do exactly this, to help you learn to profile and do it easily and quickly. And then if you want to...
Just a quick comment. We're sorry. Usually we show like the time more obviously, but we're a couple of minutes over the 5-minute mark.
Oh,
and
wow.
To make sure that everybody has time, I think Ting has, so sorry, we're learning how to do this too. Ting has a clock that maybe she will operate, but she's juggling also making sure people get into the session.
No worries.
Please keep going. We want to hear what you have to say and model the way for the next speakers with, making your time. Thank you.
No worries. Sorry. I had these on auto and I don't know why they're not auto going.
Yeah.
Okay, so yeah, the approximate statistics are great, small storage, computation, data analysis friendly. So I want to thank you and just have conversation about kind of what differences have you seen across industry and academia, and what practices can come to bear kind of from both sides, and joining that conversation. All right. Sorry for running long.
We're good. So with that, do we have any questions for Baessas? Well,
I don't think I have a question per se, but maybe like a comment. So I've been trying to look into value of data, trying to understand, how people price data in data markets. And one thing that I've noticed, when it comes to how people sort of compute the value of data for machine learning, there is that assumption that data is static. So they compute value of data, like when it's like a batch or something like that. And like, of course, I think when it comes to pricing, it might, change if like you look into data being dynamic and all that. So I don't know.
Yeah, that's really interesting. I think pricing is a really great example of that because you have kind of two parts. So you have the potential to grow data, which is helpful, but then you also have probably the aging of data will affect pricing. So it seems like both ends, the dynamics really affect it.
And also, if I can add, you can refer to my PhD thesis. So it's about amount of data versus diversity in data.
Mhm.
I showed if you get data from minority, for instance, speakers with Glaswegian accent, which is on the tail that you showed of the distribution,
Yeah.
a small amount of data from like a minority group can help your system get out of local optima and have more positive impact in the model accuracy compared with just having 20 times more data from the distribution that matches the majority. So
Yeah.
just something to add.
That's great. Awesome.
Amazing. Thank you so much for this powerful talk. And if folks want to ask more, you can, perhaps share questions in the chat and make sure that there are answers also in the chat, or we can follow up with you and ask them. We just learned that our Twitter space has exited unseemingly, but we will restart it, so that should be okay. And we'll post another link to the Twitter space. But wonderful. Thank you, Bernice, for your words. And going to our next speaker, Magdalena. Take it away.
Hello.
Yes, we can hear you.
Great, but I want to share my screen.
Okay. Can we help? Are you okay?
Can you see the slides?
Not yet, but
Maybe could we get to the another participant and we will back to my presentation, because I don't know why I cannot share the screen. Sorry.
that's right. Say, of course. So now I'm going to ask, is Gishma actually here? I'm not sure I see Gishma on here. So maybe Casey Simone, I think we need to go to you if you're good with that.
Sure thing, no worries. Let's give it a go.
Awesome. Thank you.
So is this working for everyone?
Yeah.
Yeah, seeing nodding. Okay, let me also make sure I see the timekeeper on my sidebar, or I'll just set a timer. Yeah, okay, there you are, Ting. Thank you so much. So hi, my name is Casey Simone Baessas, and I'm housed within the Faculty of Industrial Design Engineering at the TU Delft. So perhaps a little bit adjacent to some of your guys' domains. My particular research is within exploring how both designers and engineers create spatial computing. So spatial computing comprises everything from virtual reality all the way through to ambient intelligence and autonomous robots. Essentially, it's computing that is exteroceptive or perceptive of the environment around it. So of course, there's a lot of reliance on computer vision to make this happen. and actually, I'm really reminded by some of the things that you shared, Bernice, in this model. But what I was actually hoping to speak with you all today about was just the idea of data sets as ground truth, especially when we think about them across the entirety of the product development cycle. So not from just these kind of pre-constructed data sets that we leverage within machine learning, but also thinking of them as things that ultimately end up in some sort of physical, often hardware artifact that ends up in some sort of consumer situation. So of course, we're familiar with the complexity of the ethics around data sets, this one being a very classical one, of course, used to do facial recognition training. And right, there's a question around, is it really appropriate to be using imagery of folks that maybe haven't consented? These, of course, are folks who've been incarcerated for some period or another. And I'm really excited that that is a question that's really emerging in our field, but I think there's also maybe a more nuanced question that we want to ask when we're thinking about these cross-domain uses of data sets. So I think Kate Crawford from Microsoft Research said this really well in her book. She asks, in what ways does training data limit what and how artificial intelligence interprets the world? Well, in the field of product development, this is how. So basically you take a data set and you probably know very little about it, and then you implement it in your product. What does that mean? It means that the expertise of what's happening within a data set and the complexity therein, there's a gap between that and what's actually happening in the product development space. So to make that really concrete, let's use this example of, a design team wants to create an application for augmented reality glasses that can let a user know what somebody's emotion is. So they take a data set responsible for training on emotions, and that, that data set has hit some benchmarks in the literature. So they're like, okay, let's go, we're going to use it. They ship the product, the app, and your user is looking at a gentleman like this who's making this expression, and you think to yourself, okay, what will the glass app tell you? Will it tell you that he's happy, that he's mad, that he's confused, that he's expressing, I don't know, something else? Well, whatever it tells you, it probably doesn't know that this gentleman has just had a stroke. And so this is actually a real paper that shows that, the difference in facial structure after these kinds of events. So my curiosity for our community is, how do we bridge between kind of this historically siloed into computer science, which is data sets, into the reality that they are going to be applied and likely misunderstood and misleveraged within the product development world. So it's a really open question. It's something that kind of keeps me up and something I'm really curious to think with any of you all who are thinking on this topic. And I'll leave you with a quote that I really love, that I think about when I'm thinking about how data sets, especially those that involve computer vision, will be used. It's from John Berger, a great book, Ways of Seeing. If you need a nice read for the holiday period, I'd really recommend this. He says, we never look at just one thing. We're always looking at the relation between things and ourselves. And I think us within the machine learning community understand that for our data set themselves, and then also as individuals, I think we have some appreciation of that. I think the thing that I'm really excited to see is how we start to extend that between our domains to ensure that, folks are really seeing with complexity and integrity. So thanks so much for hosting this. It's really, really lovely to be here, and I'm looking forward to the rest of everyone's talks.
Wonderful. Thank you, Casey Simone, for sharing. And would love to hear if we have any questions.
I perhaps have a comment. It was a great talk. I think one thing you seem to be getting at, that I've heard the term before in the social sciences, is boundary work and boundary objects, so that when you have two fields, there are kind of things that you can communicate across fields with, and that's a boundary object. And data sets, I've always thought that data sets are kind of a great boundary object in AI and adjacent areas.
Yeah, I love boundary object theory as well. It's definitely something that we employ much more towards the design heavy side, but so hard to conceptualize. And yeah, data sets make that kind of tangible in an abstract way, for sure. I love that you said that.
Yeah, thank you so much. And anything else? Questions? I was going to take a microsecond here and say, you know, this is about women in AI and supporting this community. And I just wanted to give a shout out. We seem to have here on the line with us the executive director of NeurIPS, Mary Ellen Perry, who does so much work to make sure that this conference happens. And from back in the day when things were in person, and if you've ever tried to make sure that anything is organized in person, you know how hard it is, and it's only you know, different hard now online. So thank you for all you do. And then okay, so it sounds like Magdalena is up online. That's good. So let's go ahead and hear from you. Welcome.
Hello. Hi. So I hope you can see my slides now. So my name is Magdalena Wierciok, and I'm from the Jagiellonian University. And today it is my pleasure to talk to you about my research tasks. So firstly, I would like to introduce myself. I'm a PhD candidate and a programmer and a machine learning researcher. And my research interests are related to machine learning and deep learning. And to specify, the great majority of projects I've been involved in so far are connected with the development of methods to improve various classification and regression tasks. And a few studies were related to clustering methods and interpretability issues. Of course, one of my main research goals is connected with drug discovery. So I will tell more about that. So drug discovery is a complicated and systematic project that usually is spent over from 10 to 15 years. And in general, it is a very long journey for a drug from invention to market in practice. And meanwhile, due to the complexity of biological systems and large number of experiments, drug discovery is prone to failure and is inherently expensive. And to address these issues, of course, many researchers propose many different computer-aided drug discovery approaches. And they are extensively used. However, despite the success in drug discovery, traditional methods are mostly based on molecular simulation techniques, and they suffer from the huge computational costs, and they are time-consuming. And these factors limit its application in pharmaceutical industry. Yes, and in general, my research goals connected with drug discovery are related to two types of tasks. The first one is connected with properties prediction, molecular properties prediction. And the second task is connected with the generation of new molecules. And now I would like to tell more about the project I've been involved in, just a few projects. So in order to deal with this topic, I have to mention about the one of the most important problems that are connected with drug discovery. It is representation. So the current molecular representations are not can be improved, and they are not sufficient. And one of the paper, one of the project I was involved in, proposes new moment invariants that solve two-dimensionality problem. And in general, the goal was to propose a new representation that can be fed into a machine learning model and describe a different object in a better way, and not necessarily molecules. But one of the experiments involved chemical compounds as well. Yes. In the second study, we focused on improving molecular activity prediction. In general, molecular activity prediction is one of the most important challenges in drug discovery. So here we introduced a methodology that is that involves probabilistic classification vector machines and spherical harmonics-based descriptor. And the presented method was applied to GPCR datasets.
Dear Magdalena, sorry, we're a couple minutes over the 5-minute time limit, and
okay.
we need to make sure our next speaker makes it to an appointment they have to go to. So let's
speed up
and wrap it up. Thank you so much.
So here we proposed another method that is focused on a generation of molecules, and two another tasks were connected with molecular properties prediction. So if you are interested in this type of project, feel free to contact with me. Thank you.
Wonderful. Thank you so much. So I think if we have questions for Magdalena, it might need to happen over chat, and or if you wanted to, stay over after the session is over, we could probably have a couple of minutes talking out loud, though it might get late for folks like Magdalena who are in another time zone. With that, I was wondering if we could make a small change, Dr. Dillon and Dr. Medina. Could we possibly ask Dr. Medina to go first, because Dr. Medina has like a hard stop a few minutes before the bottom of the hour, but I think both of you will fit comfortably into the hour itself.
I just have to go teach at 3, so I also have a hard stop, but but I think if we stick to 5 minutes, it should be fine.
Yes. Okay, so Dr. Medina, take it away, and then Dr. Dillon, we will hear from you. Thank you so much.
Yeah, thank you so much, Dr. Dillon. So I'm going to stick to the 5 minutes. This is, let me just share. Let's see if I can share screen here. And then I'm going to say a few words about myself. Let's see if I can just I don't like this view. I don't know why this is taking all the, yeah, it's already counting, right? So let's see.
It's okay. I think you could hit that arrow to the right of the slide deck and it will make it smaller. Like, you see where your slides are? There's an arrow there, yeah.
Yeah.
If
For
you
some
hit that,
reason I reduced this. Oh, there you go.
okay. Anyhow, we'll let you deal with it. You are on location, you know what you're doing.
For some reason this. Okay, so if everybody can see this even in this weird way.
We can't
Oh,
see
there
it.
you go.
Yeah, okay, this is a little better. All right. Now we can see the entirety
Okay.
of the slide, but yeah, perfect. Wonderful.
Given the time. Yeah. So I'm going to say a few words about myself. I'm an assistant professor in Yeshiva University, and my main training is in mathematics. I'm all the time trying to insert mathematics in all my talks, but I decided that since this is going to be a 5-minute talk, I'm going to pretty much make it like more general. I'm going to talk about my research in a more general way. I'm very passionate about applications to the sciences. So I work in a computer science department, so I need to be more. And so talking about the data, I'm going to talk a little bit about the data I'm going to be presenting today and the methods, trying not to be very technical, but I work with something called LiDAR data. So just imagine 3D point clouds modeling environments. And then in this case, you can see an aircraft that is pretty much scanning a terrain. And then pretty much I have a laser that is collecting all this nice information about elevations of trees and lakes and all the wonderful things we have in nature. So what am I doing is that I'm pretty much with that airplane is going to have a LiDAR sensor that is pretty much collecting all these reflections, all these returns from the laser energy that was sent to the object or the target. And then I'm going to get estimations of the spatial coordinates, X, Y, Z, and other features, okay? So then this is an example of a nice picture that my a colleague from the USGS, Jason Stocker, shared with me, which is the Golden Gate Bridge. And then we have water. He has a nice visualization software that shows you the LiDAR. And then pretty much I have vegetation. I have this nice like courts from the San Francisco Bridge, like the Golden Gate, like with the different features. So the thing is that I'm going to be trying to focus on a classification problem. So in this particular picture, the main elementary classes are water, vegetation, ground. I forgot to mention ground, and the man-made structure, which is the San Francisco Bridge. So one of the features, again, it's not just XYZ features that I see in the space. I always have LiDAR contain other features, such as intensity, number of returns, because it penetrates through objects. For instance, for trees, it can penetrate through branches, et cetera, et cetera, et cetera. GPS time, because I need to estimate elevations. And the scan angle, sometimes the laser doesn't go directly, right, to, in this direction, but also it can take a little angle to collect data. So, and the thing is that this is the idea that LiDAR is penetrating that, and that's why it's such a good data set, because, optical sensing method system, because it's pretty much collecting everything from branches of a tree until it gets to the ground. So for the next example, if I have time, I guess I have like 1 minute and 38 seconds. I have classes and my next, such as ground, noise, and water, right? So in this case, I'm trying to do some feature engineering with the data. And then the main picture of this is doing feature engineering. That means using the basic features of the LiDAR data and producing new features. Once I produce new features, what happens is that I'm going to have a high dimensional space. And if I have a high dimensional space, I need a dimension reduction method. So in this case, I'm trying to compare PCA, principal component analysis, as a dimension reduction method on autoencoders. That means the inner layer of an autoencoder of a neural network. And then finally, after I do these steps, I apply any classifier. And I'm not going to be showing numbers today. So then this is the Rhode Island, like I guess the JFK airport in Long Island. and the coordinates for that airport. Here is just an example of how I did feature engineering using the neighbors. Like this is your spatial data, the dimension reductions, and this is what I'm saying about using like the inner ledger, which has less like the minimum nodes I need to perform dimension reduction. And this is a picture of, by the way, I was so pleased to see the eScience and eScience Institute representative here, somebody working in the eScience Institute, because this was taken over there when I went to the GeoHack week, and it was so much fun. That's a LiDAR data set that we did there. So the scan was with a tripod from the sensor, like the LiDAR sensor lab in University of Washington. So thanks for your attention, and I think I'm out of time. Thanks for the invitation. I really love interacting with these wonderful women who are doing wonderful work. And then I just encourage you to keep doing what you're doing and keep going. Never stop. Thank you.
Thank you, Dr. Medina. It's exciting. Do we have questions for Dr. Medina? I guess I'm going to maybe speak for Ting and myself and say as, oops, I'm so sorry. This, okay, I don't know how to stop this, but spam is calling me, but we do. So we at MathWorks, we work with MATLAB and Simulink and work with LiDAR, you know, and be very curious to know if you have encountered any of these tools that we build and look after, but also if you, you know, maybe there seems like a lot we can learn from you. So would love to read up more on your work. That's not really a question, but a statement, because I think we need to ask Dr. Dillon to speak if the if our commitment to her is going to be kept. Okay, thank you.
Thanks.
Yeah.
I think I can't share until.
Yeah, Dr. Medina, you might need to stop sharing.
Okay, great. All right. So I just thought I'd give a couple of notes about some work that my team is presenting at the workshop here, because it's really exciting for us. So the question that I ask in my research is, how do we build artificial intelligence that looks like human intelligence? I study infants and children's precocious knowledge about the world, from the objects and places in it to the people and animals that act on those objects and move through those places. And I ask how that knowledge derives from our evolutionary inheritance and how it forms the basis of our uniquely human cultural and intellectual achievements. And the early developing ease and abstractness with which human infants even know about physical objects, other agents in the environment, and the places we navigate are impressive, especially compared to the difficulties artificial intelligence has had in achieving these simple human competencies. And I want to give you an example here. So take a look at this video. So for example, while infants have a rich common sense capacity to infer the underlying goals and preferences of other agents merely by observing their actions, like these kinds of actions. So we are all kind of getting a sense of maybe the goals and dispositions of these simple geometric shapes. AI systems, in contrast, don't have those inferential capacities. They instead are able to do things like predict outcomes of interest, churn, clicks, likes, but do so without representing the goals and preferences that underlie such outcomes. And these differences between human and machine intelligence are critical to address if we aim to create machine common sense, leading to AI that we can better understand and that can better understand us. So back to the presentation. So in the work that I just wanted to briefly chat about today, the goals for us were to put tests of human intelligence in direct dialogue with tests of AI. So to create a suite of tests or benchmarks of intelligence that can be used to evaluate both infants and computational models, and provide a test bed for computational models with different priors and learning-based approaches to achieve common sense reasoning about agents. And so our team is currently building these tests of common sense appropriate for testing both infants and artificial intelligence systems based on early emerging and phylogenetically ancient domains of abstract knowledge, including about agents, objects, and places. And so our first benchmark, the baby intuitions benchmark, challenges AI to recognize that agents have preferences for goal objects, act efficiently towards their goals, and engage in instrumental actions to bring about their goals. So the acronym for Baby Intuition's benchmark is BIB. So BIB includes one canonical split between the training and test data, allowing for a truer test of abstraction. And BIB's design is adopted directly from infant cognition literature. So it has a classic looking time paradigm. I can tell you more about that towards the end, allowing us to put human and machine intelligence in direct dialogue. So in our paper, we present the benchmark and we test 3 state-of-the-art deep learning models, video modeling, behavioral cloning, and offline reinforcement learning as baselines, including architecture inspired by a theory of mind net. You can check out the citation there at the bottom. And these models failed on any of BIB's tests requiring an understanding of preference or rational action, leaving it an open challenge for machines. But I thought I'd also mention that we're testing BIB directly on infants as well. So here is my next little example. Here is a baby participating in our benchmark. So what we do is we present babies with the same kinds of displays that we presented the models with. So you can see that these displays that the babies are watching are in a really familiar kind of context when it comes to testing machine learning systems. They're seeing these grid worlds that have different kinds of characters in them. And what the baby is watching is this agent here moving to its preferred object, this blue shape, again and again. The baby sees this about 8 times, and the baby gets bored. Machines don't get bored, but babies do. And by the time the test comes around, now the preferred object is in a new location. And the question is whether the baby or the machine will expect the agent to move to a new location where their preferred object would be, or a location that they had previously visited, but no longer has their preferred object. And so babies make predictions that agents have object-directed goals, not location-directed goals. So they would find this kind of outcome surprising, where the agent is now going to the green object as opposed to the blue one. And babies show us their preferences and their expectations by looking longer at certain outcomes. So we adapted that kind of paradigm for testing machines as well. So our initial findings with babies suggest that infants actually succeed on the very tests that machines fail on. And so it's worth noting that, again, these successes for infants are not trivial because the data set is really appropriate for testing machine abstraction and generalization. So we're excited about this work because it presents a general framework for any benchmark aiming to examine common sense reasoning in minds and machines, as well as bridging the gap between machine impoverished theory of mind and humans rich one. That's it.
Thank you, Dr. Dillon. And friends, if we have a question, maybe there is a time to say it quickly. We are going to be a little over time for our bottom of the hour. So if, we have to be respectful of everyone's commitments and make sure that we try to maybe do that. So it'd be ideal.
I have a super quick question, but perhaps it can just be found in the citations to this paper. I'm curious if what you found suggests then that localization preference is just a bigger preference altogether, or if there's still some inquiry into whether object or localization preference in humans has been completely determined, if that makes sense.
It's pretty well determined. I can give you a link, but basically since 5 months of age without any kind of training, babies expect that folks will reach for a particular object, not to a particular location. I mean, you can imagine just in your everyday life, right? You're probably not just going somewhere to go somewhere. You're probably going somewhere to get something. So it's a really early emerging intuition that babies have about what are the underlying motivations of people's actions.
Amazing.
Great, thanks. Where can I find you to get that citation?
I'll put it in the chat.
Would be a great place to follow up.
There
Thanks
we
so much.
go. And also we put a link to the poster that I looked up quickly. So if there are other things you want to share, certainly we'd be happy to have your citations in the chat, and we'll find some way. There is a Rocket chat for the session where you could continue also the conversation. But let's see. So Dr. Rastogi, I want to say you are our next speaker. Are you ready?
Definitely. Okay, I'm going to share my screen.
Awesome.
Oops. Can you see my slides?
Yeah.
And okay. So still seeing the larger screen?
Yes, it's good.
All right, perfect. I'm going to
It's
start
good.
now. Okay. Thank you for having me today. Hello, everyone. I'm Rastogi, and I'm an assistant professor in AI and security at Rochester Institute of Technology. And I'm very excited to be talking about presenting a talk on contextual security. This is an area of research that I've been working on for the past 2 years. Overall, my research uses artificial intelligence and other, like graph analytics and machine learning and whatnot for improving security posture of various infrastructures. So cybersecurity has, as we speak today, has transcended technology-driven industries, and it has entered into our lives in a way that the devices around us, healthcare, our lifestyles, and certainly cyber physical systems. So basically the entire spectrum which is connected by internet. If it is connected by internet, it needs to be secure. So as you can see in this chart, just a second, the wrong window showed up. Okay, just let me minimize this. Where did this come from? Okay, sorry about that. So as you can see in this chart, that attacks have occurred across industries. Malware attacks, distributed denial of service, email compromises, misconfiguration, data theft. I understand most of you are not as familiar with the types of attacks, but I guess some of these terms might ring a bell, that there have been malware attacks and email compromises and data theft and so on. And these industries are, I'm sure, familiar to most of us. I don't want to make it too technical, but certainly cannot completely take away from that. Okay, so how AI is being used in security, I'm going to very briefly touch upon it. That AI, mainly machine learning, it is being used, and in fact, it is playing an increasingly prominent role in security domain, both in defensive and offensive scenarios. Google uses it, machine learning, to analyze threats against mobile endpoints, which are running on Android, a platform which is managed by Google. And Amazon launched Macy, which uses machine learning to uncover and sort and classify questionable data stored on the S3 cloud storage services. And there are other security vendors using deep learning models to learn complex features. But what has been argued against machine learning is that while it shows a lot of promise thus far, it also produces an unmanageable amount of alerts, which causes fatigue to security analysts, and they have limited ability to learn from and interact with human operators. And there's also lack of interpretability of the alerts generated. So interpretability in security is another aspect of research that I've been working on. So my research goal and the topic that I'm covering today is to address these drawbacks of machine learning, and and instead of using pure machine learning for attack detection and prevention, use contextual machine learning and other AI techniques. So we don't just look at one thing, but at relation between things. That's what Cassie Simon said in her talk. So I just picked that up because it applies to my talk as well. So let's talk about what is contextual security. Very briefly, the core idea is to improve all kinds of learning from source data such that models can disentangle underlying explanations to understand and describe the context in an application domain, and specifically in security. So we need contextual security because we don't want to omit human in the loop, but we want to recognize when to bring in human in the loop, such that automation doesn't get compromised, but at the same time, there is also enough context behind alerts and false positives that can identify when to bring in human in the loop. So that's another aspect of contextual security that I'm researching on. So I'll summarize my research progress in one of the projects. So I know I'm almost on time. So what contextual security in my case means is that there is this unstructured data source written in the form of human natural language, and which gets converted into a graph, a knowledge graph, and the nodes of that graph basically are connected using some sort of a relationship. So this very small text gets converted into this very small knowledge graph, and then extrapolating this turns into a much larger knowledge graph. And that's basically what my research has done. And we are among the first ones to do that. And individual triples now extrapolated to larger knowledge graphs, which are the smallest unit of knowledge graphs. They are encoded into embeddings. And then there is latent knowledge transferred across these embeddings. And finally, what we get from this latent information is a graph that is able to make predictions. So essentially converting that unstructured data into some sort of structure on which machine learning models can be run. So to give you an idea of how predictions are made, we send a query to this knowledge graph, and the knowledge graph return results. And that results are not just whether there's an attack or not an attack, but also what type of information does the query indicate. So for example, we just enter this query into the knowledge graph, intelupdate.com indicates. What does it indicate? It indicates the name of the malware family. And in another use case, there is this coronavirus themed attack targets. So the result from the knowledge graph gave us a set of countries, a set of industries, all those that were targeted by coronavirus themed attacks. So I know there's a lot under the hood that I would have loved to cover, but I just wanted to give you a gist of what my research is on. And I'd love to take questions.
Okay, yeah, we might be able to squeeze in one question here. So any questions, friends? Okay. Well, if you come up with something, you can post it in the chat, and also look for Dr. Rastogi on the Rocket Chat sort of lines. And but thank you. This was inspiring and terrifying at times, as our work with security can be, or our work with ethics can be. So yeah, awesome. Okay, okay, sorry, I apologize. We have Amel, who is, I think, with us pretty late into the evening, and we're so grateful. Let's hear from you on your work. And then last but not least, Keziah will close, and we are looking forward to your work so much. Sorry, it's a little over time, but thank you for everyone's collaboration to get us to this point. Awesome.
Can you hear me?
It's good.
Cool, great. Thank you very much for having me. My name is Amel. I'm from Tunisia. It's a small country in the north of Africa. Today I will talk mostly about intelligence, asking questions here and there. But before that, a little bit perhaps about myself. I'm a research engineer at InstaDeep, which is a company based in London, Paris, Tunisia, of course, and other places. I'm also a Google developer expert in machine learning and a mentor at the Google for Startup Accelerator in the MENA region. Yeah, I've been working lately on the intersection of biology and machine learning. I've also worked on natural language processing for Arabic language and computer vision for oil and energy kind of industry. Yeah, apart from that, today what I wanted to share is actually questions related to intelligence. And basically, I'll be talking about the different kind of basic questions that I have, which are like, what is intelligence? Why intelligence? How can we achieve it? But this is basically going to be all about questions. I'm not going to try to answer any of them because I obviously don't have the answers for them, but this is helpfully to help share or trigger the processing, the thinking process for each of one of us. So my main question would be, are we there yet? Or are we able to create, or will we be able to create artificial general intelligence? Because this is what we are here after all: machine learning, intelligence, machines, and human intelligence. And the difference is like the difference between humans and machines. So basically, what is AGI after all? Why do we want to create something like that resembles humans? Is it to surpass the human being, or just we want to create something that is like help the human being to reach a certain level or to achieve things that other human beings alone cannot achieve? For example, like discovering other species, going to Mars, or anything like that. But do we really understand intelligence? I mean, there are different types of intelligence, right? Obviously, machines are better calculators than like human beings. But what about and what about obviously, for example, machines that are, for example, drawing using GANs? Can we classify them, for example, as like machines that are able to that are intelligent, or we cannot say something like this? And the other questions that I have are like, can we say like intelligence is specific? Because human being, as much as general they are, they have specificities, because some people prefer art to sport, other people prefer math to sports, for example, or any other thing. And what about the emotion in all of this kind of effect? So the general questions that I want to ask is that, what is really intelligence? Is it knowledge? Is it understanding? Is it consciousness? Is it problem solving, or memorization, or thinking, or even attention? I mean, or all of them together? I mean, for example, Richard Feynman like to say knowledge is not free. You have to pay attention. And one of the things that we have nowadays is that, or the trend nowadays is that attention in the machine learning, for example, framework or papers, like attention is all you need, MLPs is all you need. But I strongly believe that we need something, or we need a little bit of everything to get to what we really want to get, and to achieve the artificial general intelligence. As another thing that I really think it's really important as in the machine learning community to talk about is emotions. So basically, what we think about emotions. Are emotions related to intelligence? Can we classify emotions to something really important to achieve intelligence in a way or in another? Can we incorporate these emotions into machines, like, for example, anger, hatred, or boredom, like the or I don't know, kindness, or anything like this? So these are kind of questions that I believe we should ask nowadays, especially related to machines and then what we want to achieve with them. And yeah, perhaps another question before like closing up is that, what is intelligence, a discrete or a continuous process, or is it a bit of both? I mean, do we have like intelligent moments, or like if we are intelligent, we get it in one go, and we cannot improve it in a way or in another? Yeah, and lately, lastly, for a final thought is like, why do we want to map machines to humans? Why don't we try to understand ourselves before trying to understand how the human behave, and try to find the middle ground between the mapping the machines to humans? And this is what I wanted to talk about today. Thank you for having me. But this is perhaps hopefully will trigger the process of thinking for like in machine learning in general. Thank you.
Thank you so much, Amel. And let's see, are there questions for Amel? I guess I am curious if if you have, like, you shared with us a lot of questions that are broad and all of us could be asking. Some of the questions I have are, is there anything specific to your time and place, the languages you speak, the culture you've grown up in that you have wondered about with this AI work, the impact of AI? So that's something I will pose as a question, but we'll probably have to take the answer in the chat if there are any thoughts in your head in this language or another. But because we want to hear from Keziah, and we're so sorry that you have had to be ready and patient, but we are so excited to hear from you. And I guess I will also say Keziah, in the nick of time, made it into the list of people we could ask to speak, because many people wanted to speak, but some of the other folks who asked after you, we couldn't say yes to. So we're so grateful that you made it, and we are here for you. So let's hear it.
So unlike like the other people, like the stuff that I'm going to present is not really like a research project per se. Okay, so I'm gonna talk about like a collaborative platform that we've been working on with a friend of mine. It's called Collaborate with Researchers Anywhere, Anytime. So, wait, sorry about that. It just moved so fast. Okay, so the things that we care about, we've seen like a lot of, it's really hard to sort of connect different researchers and academics and sort of pursue like all these different interesting things that people are interested in. So one of the first things that we care about was like, grad school admissions. There has been like so many amazing organizations that are trying to close this gap, trying to help students, give them financial aid to, do test scores and tests, read through their statements of purpose and all this other stuff. The other thing that we've also seen is, finding and building communities and reading groups, accountability groups. Like if you're working on your dissertation and you just want a group of other colleagues to sort of like push you through, it's not easy to find these sorts of people. If you wanted to learn a new topic and you just want to find people to sort of like, read a book with or like learn a new subject with, it might not be easy. And of course, like if you're interested in, pursuing grad school or going into industry from academia, you might want some advice from like, people who have been there or who are already doing this sort of stuff. So again, like there is like so many different amazing organizations that are trying to do this, trying to connect students, trying to find a way to provide mentorship. And I think also even just for this workshop that we are attending, it's like we are connecting and we are seeing each other, but it's again not easy because there are things like, time, there are things like, not everyone is like good at socializing. So that can become like a barrier for people to connect. So the other thing that we've also seen is that some of these groups are really very specific. Now, again, if you look at this lists that I've given, most of them, of course, are in AI, but also they're like, affinity groups, or like they're very specific, like, for example, mechanism design. And it's like, well, if you have a friend who is like maybe doing, some work in systems with ML, like you might find it hard to find a group where you actually fit in and can sort of like find help that you're looking for. So what we try to do is, first of all, create a database that has like all these different amazing groups and organizations so that people can easily access them, because even just these organizations being there doesn't mean that, everyone is going to know about Black in AI or women in machine learning. Sometimes someone has to tell you about these groups. So we want to close that gap by providing like a database of these different organizations for people to easily access them. We also want to sort of like widen the possibility of, finding people. Like if I was looking for someone to read through my statement of purpose, I could just easily just go to like the list of people that are available and, connect with someone and sort of begin a conversation from there. The other thing that we've also realized, is collaborations. if you're an interdisciplinary researcher, you probably know about this. Like it's really hard to find people to collaborate with. There are several different ways people find collaborators. This is how I think about research, but of course it's much more complicated than this. But mostly people find, like, you generate ideas, you find collaborators, you conduct research. If you're lucky, you publish this research, you give talks about your work, you review other people's work, and through this you can, find more collaborators for your work. And of course, the other ways is through, your school advisor, classmates or colleagues, seminars, working groups. And if you're an undergrad, you can also access these programs like URMs. But this is not easy to have access to. Like, for example, you have to be in school to have an advisor. So if you're in industry and you want to conduct research, maybe your manager is not interested in that sort of stuff. So where do you start? Would you talk to, that sort of stuff? And if you're an undergrad, most of these URM programs, while they are really good, they have a lot of access barriers. Like, for example, you have to have, 3 recommendations, you have to have certain CGPA. So it becomes really hard for someone who is really interested in, just doing research. So what we try to do is to, connect researchers with mutual interests and goals that are available within similar times, have compatible time zones, and of course are interested in the same collaborative relationship, whether you're interested in sort of having a senior mentor or having a peer-to-peer sort of collaborator. So the last 2 things, are job positions and also finding venues for your work. So there are so many amazing groups again that are trying to do this. There are Slack channels, there are LinkedIn, there's LinkedIn, there are mailing lists. You can go to Google and search for this stuff. But there are certain challenges. Like, for example, it's very hard to sort of find all the information, even just 3 days ago, when you have these Slack channels or even mailing lists. And of course, when it comes to job positions, most of the people usually have access through homophily, someone who knows someone and they connect you to these different positions. So what we try to do, of course, is to make it easy for people to again search through jobs, search through different venues. And also the other thing, which is sort of a spillover effect, is you're able to sort of assess how popular or how popular, a given research area is, because you're seeing all these different workshops, you're seeing all these different people that are working in the area, which can help you sort of assess, I don't know if you want to go into this area or not. And also, of course, if you're a school or if you're a conference workshop and you're looking for people to attend your workshop, just having an access to all these different people that could potentially be interested, I think it's a good thing. So that's it. Let me know if you have any questions.
So amazing, very needed. I guess we are sold on the idea of community building. And since you said Black in AI, I'm going to say, and I say this in the chat, is one of our esteemed leaders, Louver Walker-Hannon, is giving Black in AI keynotes tomorrow at 8:00 a.m. Eastern. And so I put a link in the chat to that. And also to say, if you wanted to keep connected through one of the ways we have established here, one of which is this NeurIPS Meetup Boston, that is a little community meetup that we're hosting, through which we can more easily share, for instance, things like Zoom links or just do a watch party on here. So show up for that. Now, I wonder if folks have other questions, and maybe that's where we will close. Questions for Keziah? Do we tell us your name for the record correctly, right?
Keziah is okay. So I'm Keziah Najita, and I'm also a PhD student at TTIC.
Amazing.
Doing work in human-centric machine learning.
Excellent. So Keziah, so any other questions, or any questions, I guess is what I will say. Okay, well, keep thinking about them. I am going to go ahead and like micro share my screen here and say, hey, we have, you know, we have had this time together. It is our honor to be on this journey with all of you. Please feel free to drop a way to connect with you in the chat. Use the Rocket chat for the session to communicate. And then it seems smart if you wanted to connect using something. I guess now that we know about Kazia's project, we can think about how to connect using that. But for now, like a women community of women at NeurIPS is certainly WIML, and I recommend that we just join the WIML mailing list, which I'm sure you know how to find your way to. And if you don't, come find me, I'll tell you how or something. But that seems like a more robust way of talking to each other at scale. And then, yeah, if you wanted to think about how to throw together, like how did this session come about, okay? And if you go to one of these conferences that doesn't have like a presence of women that you think it should have, and how would you help it come about, is something we can definitely tell you more about. I wonder if Dr. Sue here has anything else to add? Ting.
No, I think, Anoush, you did a great concluding speech. I'm very happy to hear all the amazing stories and see all the interesting works. And I think I already see people starting to chat with each other in the chat window. But like, I'm going to connect you in the future. I'd like to hear more about your research. That's great. That's the purpose of a social.
Yes, yes. Thank you so much. And then lastly, if I am going to leave you with some words, and, you know, what do I know? I'm not that wise, but I have learned this. And like I say, Louvera, who is our friend here, who is a Black woman in America, is one of the important reasons why we think about this. She's our sister and she is important to us. So we owe it to her to try to do right by her. In our community of women at MathWorks, she is a center and a power that inspires us and helps us sort of execute. And if you are ever going to build a community, I want to make sure it's intersectional, okay? We don't want a community of a bunch of already super privileged folks talking to each other. It does not seem like a good goal for effort, a DI effort. With that, I have like the paper poster we made at the, okay, it seems like I have some screen blurring situation here, which I apparently don't even know how to deal with. Choose virtual background, choose virtual filter. Why is it so ridiculous? Okay, I don't know why it's blurring this, but I do have like a paper poster from our first NeurIPS social that has this photo in, oh, why is it so difficult? Come on, this photo that we looked at on paper. So paper still exists, but thank you for coming on this journey with all of us, and be safe out there and keep doing amazing work. And hope we can, by being connected to you, can learn from you still as you exit here. Thank you. Bye.
Thank you.
Thank you. Bye-bye.
Bye.
I'm just a quick question here. Sorry if I don't know if I pronounced the name correctly or not.
Oh, good.
You mentioned that there is a like an email or a list, a mailing about NeurIPS for women. Could you please write the name of it in the chat? I can connect it.
So this is currently the URL for it. So like, I'm definitely not the keeper of this list or whatever, but if you go to this URL there, it has like a nice mailing list button or something. Why is this so difficult? Okay, so I don't know if this actually works correctly, but it's currently implemented as a Google group, which I can give you a link to. That's probably even better use of your time than sitting around trying to find this. Okay, so this is the current incarnation of it. I think Wimmel might be trying to respawn it as some other format, but if they do, they will post to that mailing list what they are trying to do. Okay.
Great. And do you have a couple of seconds for another question?
Sure, sure.
So I didn't really know about this group, and I am going to be presenting a poster on Monday about the ML in science, so
Yeah.
AI for science. But I didn't know that there exists this track for women, and so I am doing other research. So how would I approach it about if I would like to present at these venues for women? Like, is there a special track that I need to apply to, or how is it being selected?
Right. So this particular session is kind of a community session, NeurIPS. So NeurIPS has this institution of what are they called, the NeurIPS socials. And at some point in the year, they advertise that it's a call for socials, and you can propose a social about whatever. Like, let's say you love, like somebody proposed a social this year about how to make a good presentation, which, bless their heart, is a good thing to learn about, okay? But what I had proposed back in the day, and back then it was more scary because like I was new to NeurIPS and it was physical. I had to pay $500 out of pocket to get, which certainly wasn't something I took lightly, but to get AV powered in the room or something. So at least this day and age, we don't have to do that. So I proposed a social, and that's how it came about. But now that it's there, you know, we usually promote this and other similar events on the Wimmel mailing list. So you could, by joining that, you would hear about things like this. It has a ton of traffic, so you'll hear about a ton of other things you probably don't want to know about. But I mean, some of it is like research opportunities and stuff. And then what else? Yeah.
Does it also have collaboration opportunities, like collaborating?
Yes, absolutely. So Wimmel itself has a Wimmel workshop that's actually happening. I want to say partly today, partly tomorrow. So go to the NeurIPS schedule and be looking, or like be looking at whatever.
I see. It is on Friday. Yeah.
Right. So there is a bunch of stuff happening on Friday, and you can actually go into the social rooms and have conversations, and like there are round tables or whatever. So there's plenty of still time to do something. So I think my answer to you is be looking things up. That's good. Be signing up for this mailing list for the future. And then the other thing is, today you're in school, is it? Or you're a new graduate?
No, I'm actually an industrial researcher / research engineer. I work for a robotics company in agriculture.
Nice.
And we do all kinds of research to kind of make agriculture more sustainable and use less chemicals, or do electric weeding and other things to not harm the planet.
Yeah, very good. So I guess I'm going to say to you, we are the grown-ups now. If there is something that's your idea, like for instance, you know, people who work on green ag or something, you could spawn your own session and see if there is enough folks that would care about this. In fact, I will.
Like a social for next year. About green ag. Oh, that's a very good idea. Thank you so much.
Right.
Oh, that'd be amazing.
In fact, I will go further and say, connect with Dr. Beryl Sirmasek, whose name I may or may not pronounce correctly, but connect with her. She has so she's in Europe, some places at Sweden or some such thing right now. And but she has she's cool to talk to, and also has like a little startup which applies AI and AR to is it crop diagnostics or something? So anyway, she seems like a cousin of yours out there that you could talk to.
Yeah, it does kind of look like it. Thank you so much for suggesting this. And yeah, one last thing. So basically, if I would like to present like this lightning 5-minute talk at a session like this, I need to apply in the usual way with a paper to NeurIPS and go through the process of new review, or is there some other channel
So
to do that?
we had this form that was circulated on social media and on like NeurIPS Rocket Chat. So I would encourage you to fill out your name in that form anyway. That way we can keep a connection with you. But yeah, I mean, we have like a little baby process, meaning somehow we go from people's names in this form to an actual lineup of speakers in the session. But yeah, it's not anything overly fancy. The point of this is to provide opportunities, not to like eliminate people. Okay.
Mm-hmm. Thank
All
you
right.
so much. It has been
Wonderful.
really, really insightful and really helpful from your side. I'm very happy I stayed for a bit longer and asked you this question.
Well, thank you. And thank you, friends. We do need to adjourn in part because there's something else that's supposed to be happening. But it's been wonderful to talk to you. And yeah, Christina, or how, right?
Yeah.
Am I saying it approximately correctly? You know, connect with us using this form. Okay.
Yeah.
Bye.
Thank you so much. Bye.